let's start off with just let's create our own project. We'll walk through step by step. I'm going to create a project challenge 4A. I've copied my git ignore, and this challenge 4 you can copy from challenge 3. Remember how we just copied that it pattern. We'll copy the package JSON, and once we copy it into our challenge 4A folder, anybody remember what the command is to bring in all the dependency libraries?
npm install.
npm install. Okay. Do we really need it for this project?
No.
Yeah. No, we don't need it. No, we don't need it, but it's always good practice to, just bring in libraries if you need it. And especially since we're copying the package JSON, it will need all the dependencies for stuff to work. But like I said, we don't need it for what we're doing right now, because everything that we're doing now is core to Java. We're not using any fancy libraries. We're not. One of the guys said that, remember I told you we had one guy who got his code running about 50% the speed of mine. He's actually using quite a few array functions to do his work for him. So he's not looping through the arrays. He's not doing a lot of the stuff that we would be doing. So that's why his code's faster. And it is exact. And the funny thing is, we actually measured our code today. His code is about 40 lines, and my code's about 80 lines. So it's amazing that his code at 40 lines runs half the time of my 80 lines, which kind of makes sense, right?
Mm-hmm.
So,
I have a bunch of programs like that. It's beautiful.
yeah. So that comes to the I don't know how many of you guys have heard about recursion.
Mm-hmm.
You have heard of recursion? Okay.
Yeah, that's what I used for mine, was recursion.
Yeah, so recursion is awesome because recursion, yes.
I'm going to be in the office.
Okay.
If anybody else comes and texts you,
Yeah.
just ping me and I'll go down and get them.
Okay, sounds good. The awesome thing about recursion is basically you are writing one function to handle itself. You call the same function over and over again, and then you eventually have a breaking point where it reaches the stop, and then it traverses the whole entire recursive function. So it's just looping itself and then goes back, adds all your numbers together. It's beautiful. If you ever have any experience with Ruby, you can write the whole entire recursive function in one line of code.
Here,
Yeah.
Python too.
Yes, in Python as well. But I dare you to go try to walk through that code, because if you step through that code, you're going to be stepping on the same line of code over and over and over again. And
It's really hard to debug.
It is extremely hard to debug, but it's brilliant and it runs really well. But until you find a bug, and then you're like, maybe that wasn't a good idea. So, what do we do for this one? Well, this one here, let's see, make sure I'm in the right folder. Okay, I'm going to remove all these things that we don't need. Okay, boom. So the only thing that we have here is challenge 4 suite, and we're going to remove this driver. Let's just clean this up. We don't need the before and after function because they are not needed. Okay, so the only thing that we're going to have is our it function.
Could you say a little bit about it? I don't really know what it is.
So it is kind of it's a function that Mocha utilizes.
Okay, it's a Mocha.
Yeah, and it's actually not just Mocha, Jess uses it.
Mm-hmm.
Yeah, a lot of behavioral driven automation frameworks use it. And the reason why they use it is that they're trying to make it easier to understand. So it should do something. What is your code trying to do? It should do this. So then you understand, okay, that's my documentation in itself. And also if the function fails or it returns an error, you know why it returned an error. I was expecting this number and it came back. So you already built in your own little debugger that you can understand without even knowing about it. So that's why they use the it function. But in reality, it's just a function call. Okay. So here's our skeleton structure. What do we do after this?
Well, you pass the function from the other thing.
Yeah. But here's a question. Do we write everything? Can we write everything down here? Can we say function?
Yeah, you could.
We could, right?
Mhm.
That there's nothing wrong with that. But is that code reusable? Okay. You can program this all in one file if you want to, but the suggestion is to break it up, because why do we need to break it up? And I'll show you tonight with our example is that if you have I like to think about the whole entire WebDriver class, you know, how we load up the web browser. You can have one set of steps for all your stuff. What happens when you want to do mobile testing? If you built your automation correctly, really the only thing that you need to change is your screen size. Everything else with the what's on the display, it should still work. Your buttons should still work. And if you didn't use static locators that's based on screen position, your automation is going to be beautiful, because you write one set of tests and one set of classes or methods or functions. You can test your mobile and your desktop and your web, your full desktop view. But if you did it wrong, you know, you're going to be maintaining a lot of scripts. So even the driver instantiating class, we want to make sure it's utilized over and over again. At the current client that I'm at, we have a full driver class that handles local desktop and all the way to a remote WebDriver. We can kick off a remote WebDriver. It's a little bit different than a desktop, but we have to instantiate the driver class a little bit differently. And we handle that with a configuration. So actually, let me show you that just so you can get a feel for what we have. And this isn't part of what we'll be doing for this go around. But this is the importance of breaking up your classes, and this is the exercise to break it up. You can do your Fibonacci stuff. You can do it line by line if you want to, but it's going to fail pretty quick. So that's why we write a function. Yes.
So the term modularity, that's what you're talking about?
Mm-hmm.
That there are pieces that can be moved around, reused. That's what I keep hearing and reading the word modularity.
Yep.
That's what you're talking about?
Yep.
Okay.
Yeah. Or if you're talking about in the Java world, it's going to be objects, reusable objects. Mm-hmm. Right. Why is my laptop going so slow?
To 720p.
Yeah. It's got quad cores and a lot of RAM.
When people describe objects visually, are they still using UML? Or what's replaced?
To get started, you probably should use UML so you can document how you want your function and what it's supposed to return, the variables that are inside your function, what is public, what is private. It's always a good practice to do that, but as far as in real world scenario, what developers do, I have never seen a documentation on how a function or method works that with a chain diagram of everything. So it'll be ideal, but it's not realistic. So here's our common classes right here for my project. So here's our driver. Here's a driver class. Let's see. We have a bunch of different things that we instantiate, and we can control how we want to bring down our object. We also have a WebDriver manager that will automatically download the latest Chrome driver off of a public repo and suck it down if there's a newer one. So we can't control when Chrome updates. It just updates on its own. But every time Chrome updates, it has potential to break the previous version of Chrome driver. So rather than trying to manually copy and paste, there is a WebDriver manager in here that goes down to the Chrome driver I think it's .org site, looks for the newest version, pulls it down, and we use it in our force cache. So we have all this code right here that is reusable. Anybody can call this code, We also handle IE, Firefox. So what does it look like to instantiate our driver class? Right here. We require 3 values to pass into there. Once we get these 3 values, we're good to go. So really, the reason why you want to build these classes is it's a relationship that you want to maintain to promise to somebody else that you gave me a responsibility and this is what I'm going to do. Right. So that's where we come up with, that's why we have functions. Your function that you present to somebody is a contract. Okay. So how do we build this Fibonacci? Well, the first thing, rather than just putting it all into one file, we don't want to keep it to ourselves. We're going to give it to somebody else to use. Let's create a Fibonacci.js file. And in this Fibonacci.js file, we can put our function and Fibonacci. And in our Fibonacci function, what are we going to pull in? What do we need for our function to work? A number, right? So we're going to say we need a number. And then what do we promise to return to you?
Any string or array.
The Fibonacci number, we're just going to look for a number.
A number.
Right, so we're going to do return total. Total, not total mem. Yeah, that pulled it in from. Okay. Yeah. So really, that's our whole entire function. We can write the rest of the stuff into it of what we want the numbers to be. Okay, but how does one person get access to this function?
You have to export it.
You have to export it. So this is the beautiful part of writing functions that you can export and not export. You can write function private and blah and return blah. Okay, very simple little function, but we'll show you what it's going to do. So we'll go up here and we'll do module dot exports, open close brackets, and we're going to export something. So we're going to do, we'll just call it the function as it is. So we'll do Fibonacci dot colon Fibonacci. That's where we're going to export.
Why is there a red underline under your curly brace?
Good question. What did I screw up?
Yeah.
Is it equals?
Yeah.
Oh, yeah, you are right. Nicely done.
Did you automatically get an import that you deleted?
Yes, I deleted that
Okay.
because it imported the total mem,
Okay.
which is an operating system function. So this makes this Fibonacci function right here exported. And also, if you notice, the color changed from this darker blue, is that blue, purple, to a lighter color. So that means somebody's going to be using this function now. And if you know somebody else is going to be using this function, as a developer, you know if somebody's using this function, I don't delete this function. I don't change the contract of this function. That's when you get bugs.
Yep.
Right? So as far as QA, we have to understand this of, okay, we have to do the same thing with our automation code. Because right now, with our project, we had 6 people writing automation. And people are breaking our automation left and right because they change our contracts. Well, you change my stuff, you got to change for everybody. You're not handling every scenario. But that's a different issue to deal with. Okay, so we have this module exported. Now let's go back to challenge 4. How do we import this?
Requirement.
You can do a require, or you can just do a const, doesn't matter. So I'll just do a const. And we're going to call this fib equals. I think it's the dot slash.
Yeah, it's
Yeah.
dot slash and then the file.
Dot slash Fibonacci dot. You don't need a JS on this one.
Right.
I think you imported it correctly. No, it didn't. Fibonacci. What did I do wrong?
You still have to.
Oh, yeah, I do need to require. Yeah, require. Forgot the brackets too. This is what happens when you depend too much on code complete. You don't memorize how to write the code. All right. Okay. I'll show you what a dot is in a second. So we're going to call this fib, and fib is what we're going to do. So down here we can say fib dot Fibonacci, and we're going to pass it a value of, let's say, 5. Okay, that's how we call our function. Now, what if we have, let's say we don't really need all the functions inside this library. We're going to create a couple more garbage functions. Fib1, Fib2, and we'll export those. Remember, with each of your export, you got to do Fibonacci 1, do a comma, so you can export multiple functions. Now it's exported. Let's go back to your challenge 4 again. So let's say here you're like, I don't really need all those other functions. I just want to have a shortcut to that one function I need. You can do a dot, and now you have Fibonacci. You can choose which one you want to use. If you want to use that, and now
And then you just call fib.
Yep, you just call fib 5. And we'll do the same function now.
Sweet.
So if you guys want to do shortcuts, so remember back on, I think challenge 1 and 2, we used the by.driver and creating those by and then until and the wait.
Okay.
You can access it directly like that, or you can just say WebDriver.wait, right? Okay, so now we have this imported. Let's go back to our challenge 4 project. Let's create a new file. It's called number to string.js. This is going to be our function to convert our number. Okay, so now we're going to do function, and we'll do num to string, and we're expecting a number to come in. Here's our function. We'll do module.exports. And let's go ahead and export this function. We'll just call it as it is. Number to string. Num to string. Okay, so this one here, we're going to say it's going to return us.
The first part is, can you just explain the exports syntax? Yeah.
Okay.
I mean, so I understand what it's exporting, but why do we have to say num to string, num to string?
So this right here is your pointer. Think of it as a pointer to the function that you want. If you want to shorten this to blah,
Okay, so that's the actual pointer.
yeah.
Okay.
So when you call this, let's go back to the Fibonacci. If I want to name this Fibonacci blah, and now let's go back to here, and let's get rid of this. Dot blah is what we reference.
All right.
So now if we go to here, we're going to do fib dot blah. So that's what we're exporting.
Great title.
Yeah.
Thanks, because I was wondering why we had to say it
And
twice.
that's the pull the Fibonacci function, not the other one, because we haven't pulled the other one in.
Right. But
they're both named block.
Yeah.
Yeah.
But here's the thing. The reason why you can make this as descriptive as you want. You can say num to string for this awesome class. This tells you exactly what this is.
Right.
But really to your end user, to whoever's going to use this piece of code, they don't really care for whatever name that you have, because sometimes that name is really hard to keep track of. So what do you tell them to use? It's like what's a good example of this? In our lives, we do abbreviations for a lot of stuff, right? Like STG. So rather than saying software I can't even spell tonight. Technology group, software technology group. As an export, we're going to say this is really STG. So everybody else outside the group will know STG maps to something else. So this is kind of your map.
Okay.
Okay. So and the reason why I'm trying to keep this straight of just using the function is that it keeps us straight on how the map does. But you don't have to do that. Okay. So the number to string, what are we going to try to return? What is our promise?
A string.
A string.
A long ass string.
Yes, a long string. So we're going to put string num. That's what we're going to return. But is it going to return something at this point?
Not yet.
It's going to return undefined because it doesn't know what it is. So try to define your variables. Variable string num equals. Give it a base value. Doesn't need to be, oops, forgot the equals. Equals. So at least now it'll return as an empty string. Nothing else, right? Okay, so that only returns us a string, the string representation of number. How do we get that string representation? We can put all the logic in here, but not very reusable if you only put in this function. So if you look at a number, let's say we have this number. This is how we represent 100 million, 100,000, 100, right? Well, these three numbers are the only thing that you care about in our written language. So if you develop this in a pattern, this is 100 million, 100,000, 100 is a string representation. Well, if you look at this, here's our pattern right here. And really, when you're writing a function or a class, is to simplify a pattern. So we're going to take this and say, yeah, this is what we need. We're going to call this 100 digits or whatever you want to call it. We're going to get the number of this to return 100, 200, 300, and so on and so forth. We'll figure out how to add this million and this thousand, and this one here. There's nothing else to add here, so we'll leave it blank. So let's do a get function called get num. Let's do a get num. And this one right here, we are expecting to,
Get a number.
yep, we're going to expect a number. And what are we returning?
A number in words.
A number in words, but only 3-digit, right? So we're going to do, let's make this easier to understand. We'll call this 3-digit num. Gotta remember to instantiate it. Declare it, variable, 3-digit num equals blank. Okay, so this pretty much will do what we need it to as far as our functions. But notice right here, this get num is grayed out. And if we go to, and let's pull in our number to string function. Do a save on that. We'll do a const s2n, s-ton, or yeah, s-ton equals require. Same design pattern. We're gonna, and nice thing is it pulls it up in your dependencies, or sorry, in your code complete. So we're just number to string because we wrote the function correctly.
We're not going to use get number here.
You'll see.
Okay.
So here, if we do a s-ton dot, we only have num to string. Okay. Here, reason why we're going to call this, and we're going to do a fib dot blah, and we'll pass in whatever number, right? 5th order of the Fibonacci sequence. And we don't need this line here anymore. And we really don't need this one. We don't want it, because it won't time out in 30 seconds. So now we're going to call the Fibonacci to figure out the number that we are on the 5th order of the Fibonacci. And the 5th order of the Fibonacci is 0, 1, 2, 3, 4, 5. So 3. Okay. Actually, Fibonacci starts with 0. Most people will say it starts with 1. And most examples of the code online will start with 1. They don't calculate 0. It has to be, it's not 0, 1, 3. It starts with 0, 1, 1, 2, 3.
Right, but 0, 1, 2, 3, 4, 5 is not 3.
But you don't add all of them, you only have the two.
Just 3.
Counting to the 5th position.
Yeah, you're only adding these two numbers equals this number. These two numbers equal this number.
Yeah.
And these two numbers equal this
Right.
number.
Yeah. But if are we doing it by index? Because
Where are you doing it by index?
so
Correct.
the 5th position,
It's 3.
1,
It won't come
2,
back that
3,
way.
4, 5. So if it doesn't come back to you on that one, you got a bug. So you got another if statement you got to add in there. Okay,
So is it 3 or 5?
it's supposed to be 3.
Okay, cool.
So the 5th order is 3.
Gotcha.
First order is going to be 0. Second order 1, 2, 3, 4, 5. Okay.
Is order a special JavaScript word, or you mean index, or?
No, the 5th order of Fibonacci. That's just what we call
Oh.
Yeah. It's just the 5th index.
Basic number in the order.
Yep.
so if you do the 0 order, what are you going to get?
0.
0. That's why you write your case in here.
No, so I've done that.
So we know in here it says, and we really don't need these.
Yeah, you got one lost.
Yeah, we don't need these anymore. Whoops. And we don't need these exports because they're going to be telling us there's an error. So we know in here that if number,
Less than 1. Or equal to. Less than or equal to 1.
yeah,
You return that number.
you can do that. But remember, we want to, yeah, if less than or equal to 1. But we want 0 first, right? Less than, or sorry,
You can't have it less than 0.
less than 1. less than 1, we know it's going to be 0. So we're going to total equals 0. And really up here, before we even start, we should say total var total equals 0. And I forgot my open close bracket. And I love code complete like to. So why do we do this? Why do we put a total equal here and put and return a total? Because technically we can just do a return.
Because it's easier to debug.
Yes, it is. Very easy to debug. You can do return 0 right here.
If you're gonna, I still say you can do less than or equal to 1 and it would still result perfectly. Because you're gonna print out every time that total.
Yeah.
And whatever the number is. Because the way you called it last time, this way, it works.
It does work. Yeah.
So you don't have to do 2 if statements.
No, you don't. But again, it's just, let's think about
Clarity,
it on our conscious level of no confusion.
Okay, all right, I understand.
Okay, so right here, we're going to do a return. Why is this a bad design pattern?
Because it stops at the return.
Yeah.
Well, if it's not,
What'd you say, Vern?
like, because you're always going to return 0.
Yeah.
There's nothing left here. Return.
Yeah.
Always do that.
This is a real scenario. What if somebody assigns total? Actually, let's do this. In Java, it protects the data types protect you, so that if you declare an integer variable, it's always going to be an integer. You got to convert it. In JavaScript, it does not. Okay, so in JavaScript, I can say if it doesn't go through this code block and return 0, I'm going to say total equals total plus
A string, yeah.
That converts it to a string. Guess what? You just violated your contract. JavaScript does not protect you against your contract. So if you say I'm going to return you a number, it better be a number. It's not a string representation of a number. I expect a number. In Java, this will blow up all your code. And luckily in Java, with the compiler, it catches for you. JavaScript is runtime. It will not catch that for you in your IDE. That's why we don't have any highlights right here. And if I run it right now, I'll get 2 different return types, which is acceptable, but we want to make sure that we are doing good design patterns so that we don't have to worry about, well, why is it breaking in this scenario and not breaking this scenario because I got this data type undefined or mismatched data type. You'll see lots of those errors. Okay, so that's why we do, ideally, we have 1 return. So we have total equals.
The more returns, the more tests you have to run.
Yep. Okay. If it's not equal, if it's not less than 1, and really right here, we didn't even have to put this right here. We can write the code to say if it's greater than, right? Because that's all we really care about, and put our good code blocking here. Otherwise, to clean this up, if it's greater than 1, then we'll do something. Otherwise, we're just going to return to 0. Really don't care.
It's 1.
Yeah. Yep. So back to your comment. Yeah, we could do that. But let's just make this more interesting so that we have. So if 1, we're going to say total equals 0. Else, the reason why we're doing this is part of using the if-else statements. Okay. Else, we're going to calculate fib sequence. Okay. And I'll let you guys figure out the inside of this sequence. Okay. Just remember, you do need a for. You need a for. loop. Okay, remember how you guys write a for loop? Var I is less than, what in this scenario, what would it be less than?
Number.
Number. Okay. And then how do we increment? I plus plus. You guys are on top of it. Okay. And here we're gonna do add up whatever numbers.
Yep.
Okay. So now you have the core of your Fibonacci sequence. Now let's go back to this number to string. We're going to pass this number to string a number. But to convert this number to a string value, what did we do previously? Let's do a string representation of number. So we're going to do var s number. So we're going to do a string, or you can do string underscore number. A little easier to read. So we're going to do a string representation of this number. And I'll tell you, now what we're going to do is we're going to parse this number. You can do a math problem and try and figure out, okay, if I need to do divide by 1,000, that gives me the remainder, subtract. It's a little hard to do. So we're just going to map it out. We're going to map out our string just like how we did here, right here. So we're going to do s number, and again, number plus blank string. That just converted this number, this numeric value, into a string representation of a number.
Okay.
JavaScript is easy like that.
I'm following the step.
Yeah, in Java you have to do parse, which you don't have to worry about here. Okay, now we're going to do if, actually let's parse out the strings first. So we're going to do var, we're going to do, where's my H? 100 equals, we're expecting 3 digits, right?
Mm-hmm.
So we're going to do a s underscore num dot substring.
Okay.
And if you look up here for the substring, it tells you it's a zero-base index number indicating the beginning of the substring and returns a specified location within a substring object. So right here it says start number and end number. So if you think about this number right here, let's say it's 100, like that. Here's 0. Sorry, this is 1, this is 2, and this is 3. So we're going to start at, let's do s underscore number dot length. This tells you, so if our number is 900, s dot length is 3,
Yep.
right? But this is where we want it to start. So we're going to do a -3. That puts our index at this guy, at 9. Where do we want to end at?
Or 3. The length.
Yeah, s number. Should we just do an s number? Because really it's kind of hard to predict what that is. But the good design pattern is, let's just do a s number dot length -3, and we're going to do this first. Oops. And then we're going to add 3. So we're going to say, we're going to go to length -3, and then we're going to +3. So all we're doing is these two, we're just making sure the index starts off the same location, and we're just going to plus the next 3 numbers. Okay. Now what about 1,000? Var 1,000. It's the same design pattern. You're going to copy this whole entire string, go down to here, paste it, Thousands starts at 6. And we're going to look at 3 digits. Oops. How about million? Yep. Minus 9. Minus 9. And we'll do billion. If you want to, and you can go on so on and so forth. You can stop wherever you want to.
Well,
That is crazy.
It is crazy.
I told us we didn't need to worry about parsing.
You have to for this one.
Everything. So remember, everything that we do as far as of writing automation in QA, we have to parse for something. We have to assert on something.
Right.
So if we don't parse on a piece of data, we really didn't do our job, because our eyes is what we're parsing on. So think about your eyes have to parse something. How are we going to parse something? That's why it's always parsing. Okay, so now that you have the hundreds, thousands, millions, whatnot, here we are going to do if 100 is greater than 0, if 1,000 greater than 0, and millions is going to be the same thing, billions is going to be the same thing. So we're just looking at 3 blocks of numbers now. And we know that whatever number we get back here is just going to be the number itself. And we know whatever we get back here is going to be string num equals some type of value plus 1,000. And if we want to apply this to the rest of this, we'll change this variable right here to billion, billion, million, million.
So you're concatenating the string.
Yes.
Okay.
Because we don't really need to figure out, so you write down here, we only need to figure out this part here. We don't really need to figure out this part. We just know that if we're calculating the 6th field, the digits that are 6 over, then we know that it's going to be thousands. And if it's greater than 9, we're going to be million. Greater than 12, we're going to be billion. So now we're going to do so let's say it's 100. We need to get something back, right? We're going to do string num equals some value, and that's it. But this value right here, we're going to call into a function. That's where this get num comes in. Okay, so we're going to do, instead of some value, we're going to call into get num, and we're going to pass it our 100 value. And here we're going to get num 1,000 value. and this value right here, get num million value. And here we're going to get num billion value. But the interesting thing here is that this million, this billion, this thousand, this hundred, it's all actually 3 digits. All we're doing is just saying that this order we're going to add a million back to it. Okay.
And that's why the first one, the hundreds, doesn't have a plus hundreds at the end.
Right. It's just whatever number we get back.
Okay.
So in this get num here, now we're going to go into the get num here because now we know, okay, we're going to get back a string and we're going to return this string number to whatever function we're calling. Okay. Now let's get num. What do we do here? Stuff. Okay, but there's also a bug right here too. We're gonna figure out. Actually, we'll figure out the little bug later. Let's do this first.
We're not worrying about tens and digits.
We'll figure that out. Okay. So in here we're gonna figure out the 3-digit number. How do we represent 3-digit number? How do we do a string mapping or an integer mapping into a string value?
Say that one more time.
How do we represent a integer value and map it into a string?
We do the plus quotation marks.
You could do that. But if I tell you what is 19, how do you map that to 19? The integer 19. So if I pass in integer 19, how do I have this print out as 19?
I'd use a dictionary.
Use a dictionary. What's another option? Dictionaries are great for Python.
I know. That's
Yeah.
I know.
What do we have in JavaScript?
Arrays.
Arrays.
Okay.
Yes. Okay. So we're gonna do var. We're gonna do single num array. What do we put in here?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, in string representation.
Why do you start with a blank?
Because we have 0. So remember, if we have 0, we're going to return a 0. And right here, of number, you can put a number right here.
Yeah,
If number Number.
Equals 0
equals,
or less than 1.
yeah, or less than 1. Less than 1,
Then just return 0
string num equals
0.
0.
Oh my gosh, this is so better.
Okay, okay, that
Right.
makes sense. That makes sense now.
And then we're going to do else. Then we go into our code block.
Okay, that makes sense. That's why I was curious as to why you left it like there.
Yeah. Step-by-step process of building our code. And really, you can't imagine everything that you need to do all up front and write your code linearly. That does not work. So you build it out into chunks. So now we have a body chunk right here. So this will pretty much spit out, okay, we got a 0 right here. If it's 0, I'm not going to really do anything. I'm just going to spit back 0.
Right.
Don't even do anything. If it's other than that, then we're going to have to go into here. So that's why 0 is never mapped.
Okay.
But remember, a array is mapped starting with a 0. So that's why we do 0 right here, but
Okay.
we're not going to put anything there. We'll do 1, 2, 3. And you don't have to type in this, but I don't want to type out everything and whatnot. We'll do 19.
Well, you're going to go all the way to 19.
Yes.
Okay.
So why do we go to 19?
Because those are weird numbers.
Yeah, there's no pattern in between 11 to 19. The representation is 11, 12. There's no commonality in these values here. So we're just going to map it. So here we're going to say if number is less than 20, and do 3-digit num string equals. And let's call out this array here. It's going to be single array.
Oh, you're going to use the index. That makes sense.
Yeah.
Okay, now I get it.
So the number that we get is going to be our index. Yeah. Else then we'll figure it out. Okay, so now we're going to have to declare another.
Oh, is 20? 20 is not like 31. Well, no. Okay, so how are you going to do that?
21, 22.
Yeah, I see what
Yeah.
you're saying.
So this one here, we're going to call it the tens.
Ah, there you go. I knew we had to
Yeah.
do something. Because the 10s were just oddballs too.
Yep. So now we have 0, 10, 20, 30, 40, and so on and so forth.
I can't spell words tonight. That's okay.
Okay, so this maps out your array. So in this code block right here, what do you need to do? Remember, we have 3 digits now.
So for that one, sorry, for the tens array, we left the second blank just because we've defined it already in the single num.
This is 0. This is 10.
Okay.
So if you wanted to, you can put in 10,
But you'd have 2 places for 10.
0.
Okay.
But then the likelihood of your code, it'll never index these two.
Right, because it's always gonna.
Yeah. So you can leave it as 0 or you can spell it out 10. You just won't ever print out. But to make it easier to understand, this is where we're doing 20, 30, 40, and you're going to have to do dot, 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 whatever the rest is. And you only need to go up to 90. Okay. So now we have the same pattern right here. We're going to figure out our hundredths value, and then we're going to figure out our tens value, and then our single digit value, right? So now you're going to do another, and up here, let's go ahead and convert this var s number equals number, not number plus empty string. So now that we know this s number is your string interpretation. Now we're just going to follow the same pattern up here of how we're breaking up our single digits, tens, and hundreds. So I'm not going to write the code here, so I'm going to have you guys write it in the future. So get 100 value, get tens value, get singles value.
Okay. When we just still do get num 100 with 100?
If you have 900, what is that going to return? So say 900, right?
Yeah.
but we already have 1, 2, 3, 4, 5, 6, 7, 8, 9 in this array here. So we really don't need to put that there. So what we're going to do is we're going to map this value. So whatever the value is, so you're going to say get 100 value. So we're going to say
Oh, so it's just the one. It's
Yeah.
just the number.
Yep.
Okay, I got it.
So this one we're going to here say actually we're going to do it if
Oh, E.
hval is greater than 0, then we're going to call into this code block. And we're going to do the same thing with tens and singles,
Yep.
right? So now you're seeing the pattern coming through of how we break this down. And the tens is going to be the same thing. This tens, once we figure it out, we know that this tens value will never be less than 20 because we handle the 20 case up here.
Right. Yep.
So, yeah. So here, the only time we have to handle the 20 case is when it's like 920 or 720 or 420.
So it'd be less than or equal to 20 for that value.
Yes. Okay. And singles is going to be the same thing. It's got to be greater than 0.
Yep.
But it's going to be less than
20.
Less than 20. But actually, once you break it down to the last single digit, it'll never be greater than 9.
Okay. That's right.
Yeah, because you're only looking at one number at that point. So that's your pattern for how you solve this Fibonacci sequence.
Although our single, no.
So remember, you're
Then
taking.
why do we have 19 written now?
19 is only to handle if it's less than 20. But
Oh,
we
that's
also
right.
have
You're
to
right.
handle-
That's right. You're right. That's
Yeah.
right.
Yeah.
That makes. Yeah, I had to think about that.
Wait, what's the rest of that sentence? It's gonna handle
So let's
less than 20, but not the singles.
yeah. So let's look at this. So we're gonna let's look at the number 5, 8. Let's see, 520. Okay. So the hundredths value. Let's put this number up here. The hundredths value is going to be greater than
0.
so it's going to be, we're expecting 5 in here, right? So to map this to be 5, we'll just do 3-digit num, not this, 3-digit num equals
Digits.
3-digit num plus, so whatever is there before, we're going to have to add this onto there.
Plus the single array
Yep.
index.
Single array. Yep. Of this actually hval. So this hval is where we're going to pull out of here. This hval is going to be this
Oh,
100
okay.
value,
Yeah. I see,
right?
I see. Yeah. Plus hval.
Yep. So hval get the 100 value. So in this example, it's going to be 5. So we're going to say hval. So I was going to say 5. So now we mapped it to 5. And here we're going to say 100.
Okay.
So a lot of string concatenation. And here, same thing. We're going to get a 2. So 2, and we know it's going to be the tens array.
Yep.
We're not working with tens. So we're going to do get string from tens array
So 3-digit number
will be
equals 3-digit number
tens.
plus tens h value.
Yep. And then single value, you can figure that out. And it wouldn't be 520 0 because we don't say 0. That's why we left this right here as blank.
Right.
So even if we didn't have a check for 0 and we just automatically just say, yeah, just take whatever the value is in single and just attach it, it'll still print out a null string or a blank string attached to the end of the string.
Digits.
And then finally, whatever this value is, we're going to return it to to the client that we're calling it, and that's what this functions here is going to be. Okay, so we're going to do, we'll throw it into this function right here. So it should return a Fibonacci number and in string.
Or words.
Or
It's not
words.
really a string.
Words. Okay. So now you have the working skeleton of all this code. You just have to plug in the rest of the digits. And notice right here that if we wanted to, if we want other people to say, yeah, you know, I'll give you just the 100 digits to this, you can make this exposed to somebody else. Say, yeah, you only want 100? Here's my string function. You can export this if you want to, but you don't have to. Okay, but now anybody can call your num2 string. It doesn't have to be in Fibonacci sequence. It can be, if I write a test to figure out writing a check, they can use this function. Awesome. Okay, so that's your challenge. Just go ahead and finish off the rest of this challenge here. And we'll dive into challenge 5.
Oh, wait.
Yes.
Before we jump,
Okay.
how are we getting the H value?
Remember your substrings?
Oh yeah, that's right.
Yeah.
Okay, now I remember. Okay.
Okay.
And we didn't actually define
But we didn't define
the
the,
Fibonacci sequence function.
No, you declare the function, but I'll have you figure out the logic on how to figure it out.
Right.
Because if you just go to Google,
Yeah, that's what I think.
Yeah. there's plenty of examples right here. You can use this one. Yeah, play around with this. I think this one right here is going to give you 0, 1, 2. So there's a bug in this one too. It's not perfect. Okay, so you
There
get,
are a ton of examples though.
there are tons.
there's tons. I did it 2 different ways.
Yep.
Both work.
Oh,
Yep.
I
but
fixed
we
my bug
did-
in the
We
in the
did start.
iteration.
We did start writing on the Fibonacci function. Well, that's what I called mine. But on the Fibonacci function .js file, like we did write some stuff there. That's what just sort of.
Yes, so that one there, all is doing is that it's going to handle, if the number is less than 0, we're going to return a total of 0. Else, then we're going to figure out whatever that sequence is.
Oh wait, can you go back to your challenge
Oh, gotcha.
4?
So it's the for loop where we would have the thing we found.
Yeah.
Right, yeah.
Yep, the for loop is where you're going to add stuff.
I just have to. I didn't fill out the describe, so I had what you had. We had to finish. Sorry, I need to do that real quick. Oh, I just forget that function. Man. Why do I get that?
Renee.
It's the function in the describe right now is a anonymous function, right? It only exists in this scenario.
Yeah.
Okay. I was just making sure I understood what that was. So we're just doing. Oh, you did stone. Oh dear Lord. What's mine up top? I know.
Let's see if the door stays open.
In the string. In the string.
Yeah, it stays open.
How close it can scroll down.
To string.
But now that
Dot.
there's no more beam on it.
Oh, actually, this one is actually, instead of blah now, it's,
Yeah.
I think we changed this to
Fib dot.
Function, all that's down here.
Fibonacci. Let's clean this up a little bit.
So where I did the iteration,
hmm
Almost.
would that work with the iteration?
The beautiful thing about the Fibonacci sequence is you can write it 30 different times and they all will work.
Yeah, there's tons of examples. I didn't copy any per se. I looked at them and then I said, okay, I want to do this.
The goal is not to figure out the Fibonacci sequence. I just want to give you guys a challenge that's hard enough that you guys cannot solve this without writing functions. You have to write functions. You have to export the functions. That's the only way to get you guys to get in the practice of writing a function, doing a return. Write a function, do a return.
So in the function, the way I started, I wrote the mathematics for the Fibonacci sequence. Just the mathematical, y equals y minus 1 minus 2. And then you turn that into your Fibonacci method.
Yeah, so if you
Using
look
variables.
at, I had that page up. Oh, math is fun.
Yeah, math is fun. This is exactly where I went.
Yeah, so this is,
So right there, the rule is xn equals xn minus 1, xn minus 2. So put that in, and then just turn that into a method.
Yeah, this is
That's probably how I would have
Yeah.
thought about it.
So if you understand the math, then it's easy to, yeah.
all right.
And then so if you want to do the recursive method of it, just look up recursion, and basically recursion is just calling yourself. So it means you create the function, but your function calls itself constantly to get the answer. So
Okay.
I did it both ways, just so because I want to understand recursion and keep it in my head. If I don't use it, I forget what it is and I have to read all of them every time.
Okay, so here's the start for challenge 5. So for challenge 5, this is where dynamic data comes in. Challenge 5, you're going to go to copart.com and you're going to search for, I think in the document I said search for Porsche.
That was second.
Yeah, but we're going to go back.
Oh, we're going to do the same thing? Oh,
Yeah.
oh, we're going to extend that.
Yeah, we're going to extend that.
Okay, cool.
Let's do an example of search for exotic.
Exotic.
Okay, so notice right here, there's 396 pieces of information in this.
You just love saying that.
Yeah, I'm like, oh crap, that's a lot of data to look at. How do I know that's correctly working? Well, I'm going to have you guys change this drop down to say 100 as part of your script. Once it changes to 100, I want you guys to grab the the model that is in this list.
All 396 models?
No.
Nope, just the 100 on the
Just
first
the first 100.
Now, after you grab all that data, I want you to tell me how many Cayenne S's exist on this page.
Wait, you're not making this up, right?
No, it's right here.
It's written in the thing.
It's right here. Yeah, I'm looking at it.
Don't worry, it's in the document.
It says change the drop down to show only 100 from 20.
Yep.
And it says possible values can be Cayenne S's and Boxster S's,
And etc. Right?
etc.
Etc.
Look at adding every model into an array and then sort the array in Canvas.
Yep. So right here it says Murcielago. Okay, so that's the first part. We're going to have you grab this data, and then you're going to count it to see how many of these exist. So why do we do this?
Seems super
So you
useful.
have an idea, like,
Do you like track trends?
I would totally do a dictionary.
if you wanted
If you would.
only a particular model.
Right. So what if we search
Suppose I'm looking for
for...
the Cayenne S. I don't want to look at all the other ones. I just want to know how many do I have to choose from.
Let me give you this scenario. Here on this page we have 42 Cayenne S's. Okay. What happens if I click on the sort? How many results am I expecting to get back? Exactly the same, right? Well, if you're writing a test and you're testing out the sort, guess what you're going to do? Porsche Cayenne S, I'm going to test a sort to make sure my sorting still returns the exact same set of number of values, numeric values. So I have to grab how many Cayenne S's are on this page first, click the sort, and then verify again. And if you notice that, it just went down to 41. What happened?
Wasn't
that's
tagged
sold.
right or something.
Yeah.
Yeah, someone sold one.
Yeah. So
So that's why you have people say, well, I can't verify dynamic data. BS. Remember, you can verify it. There's different ways and different strategies to verify this. How do you verify this sorting algorithm?
Well, you start with the complete data set.
Yeah.
Yeah, you start huge and work your way down, and then work your way down another way and see if they match.
Right. So how do you know that this actually changed something? What's another way? What if we did search for exotic? And we want to see, we know that the sorting will keep all of our results on the page. It's not going to filter out crap that we still need. But what if I do model?
Yeah, what if there's a model called the exotic?
Yeah. But the nice thing is when you sort by this, you know your list is going to be different. So if you have a map of your first set of data, you do a direct compare of your second set of data, are they equal? If they're equal, your sort did not work. They have to be different. So there's different strategies of why it's important to grab all the data on this page. Okay. And there's different ways to write your code to make it work like this. But for our example, we're just going to do exotic, or actually Porsche.
Yep, it says Porsche.
Porsche. And you're going to have a bunch of different options right here, and I want you to calculate how many Cayennes are on this page.
Well, how many Cayennes are in the first 100?
Yeah, first 100.
On that page.
On this page. Because we changed this to 100.
Yeah.
So are you saying when you showed us 42 Cayennes a minute ago?
That was Cayenne S. So I did a more isolated search.
It says Cayenne S though in the Cayenne S or Foxter S.
Yeah, so those are possible values that you can have.
Yeah, you have Cayenne TU, Cayenne GT, Cayenne S, Cayenne.
911 Carrera, because I searched for Porsche. So now you got different values, okay?
Right, so when let me just finish my first question, which I didn't quite get out.
Okay.
When you looked for the Cayenne S, and then you sorted it, there were 42, and then it went to 41.
Mm-hmm.
And you said, why is there only 41 now? How did you know it's sold versus it being a bug? Is this a live site or a test?
This is a live site. This is not a test site.
Okay.
Yeah, so if you look at some of these sell date times, these are actually live sell date times. So that's why I wrote this challenge against a live site, that you can't predict what your data is going to be, but you got to figure out, is your search working, and how do you write your code that today it could be data, it could be, and tomorrow it could be 5 pieces of data. What are you going to do? How are you going to verify everything?
So how come it's still there if it's already sold? What's today, the 11th? I guess I don't.
These are when it's going to be selling. The start sell date is going to be 4/16.
Oh, when it gets made public?
Yeah, when they're going to start the live auction.
Oh, okay.
Yeah, so that's why. But you could have an auction that has buy it now price, and somebody does buy it now. Like right on this one right here, there is a buy now price, so somebody can click on this buy it now, and all of a sudden this one's gone.
Gotcha.
Okay. Now, so the first part is trying to figure out dynamically how to count all these values in this in the models. The second piece of challenge 5, we know a certain set of values right here with the front end collision, rear end collision. I want you to use a switch statement. Switches are cool because it's a predefined set of examples you want, and you only need to isolate onto one specific area. So let me show you what the code looks like once it runs. CD. Mocha challenge 5. I'll show you what it should look like, and I should tell you what I'm doing now. So notice the browser didn't close. It's because I commented out my code to close my browser, because I was making sure that this, when I clicked the 100, actually really changed results. But in the browser, in your console, I was teaching this class earlier, and somebody said, "Your English sucks." And I said, "Yeah, I know." I noticed there's this blank right here. It's like, why is there a blank right here?
So that was no make.
It doesn't have a make, but why? This is part of the pattern. This one right here does not have a model. There's no text in here. So there's actually an empty element for your header. But the way that I grabbed all these elements, remember, use your XPath. The nice thing with this page is that use this data-uname lot search model because these are unique. And all you're doing is just grabbing all these elements using this pattern, and then you'll grab this get text. So look back to challenge 3. Once you figure out challenge 3, you got most of this already. So the second part, we're going to look at this front end, and because we already know the scenarios, I only care about, which ones do I care about? So, all right, sorry, here's the results. I have 12 911 Carrera, 1 911 speeds, 12 Boxsters, 2 Boxer S, 3 Cayenne GTs, so on and so forth. And you'll see a V8 Vantage because I'm actually searching for exotic instead of just Porsche. Okay, now the second part, there are 17 cars in the list that have a rear end damage, 2 with the undercarriage damage, 50 with the front end damage, 3 with the minor scratch and dent. That does not equal 100 cars in the list, so we have 29 miscellaneous I don't really care about. Okay, so this is how we're going to target. So let's say you actually are hunting for a car. You want to buy one of these records that are just a minor dent and scratch and dent for 40-50% off. Do you have to go manually search for it every day? No. Put your automation script on a timer, let it run once an hour, and the second you find something that matches your criteria, return it back to you. There is on LinkedIn, there was a guy who, instead of going out to find a job every day, he wrote an automation script to find his job pattern, and he put in a filter for which companies he wants to apply at, and the second that result matched, it sent him an email and sent him a link for his job. He didn't even have...
So he had the driver tell him to send an email?
Yeah. He wrote an email class. So basically he wrote his own crawler.
Who is he?
I forgot his name. He's on LinkedIn. I saw his video about 2 weeks ago. And he said, this is my first automation script that works for a business need.
If you see him again, will you let me know? Because that's what I've been wanting to do.
Okay. But you can build the same thing what you're doing here. Because you can go to DICE, you can go to Monster, you can go to anywhere. Put in your search results, and if the results match a value, let's say you want one of the value to be Google, right? The company name. If Google comes up twice, grab those 2 links, send it to you. So that's the importance of this lesson of how to do that. So here's some caveats to this challenge. Yeah, there's lots of caveats. So remember, you can't think of this code challenge. Think about this code challenge in terms of what a user would do, and not just a user who can actually see too. Because a user who can see is going to click on this 100, click on the 20, and results change. But what if you can't use them? You can only use partial mouse clicks. Or what if you want to combine a combination of 2? So if you know these results are going to be 20, 50, 100. So your code, you can say, I want to get this element, this drop down, click it, open it, and I want 100. You can type in 100. So you can do a send keys. Remember we did send keys? And then we can do a enter, and it will change your results. Here's a caveat. Your key on here has a different type of listener for when you hit enter versus when you're using code to send a virtual enter on your page. So when you actually send enter, it might have selected it, but the web page does not detect that trigger, so it doesn't refresh your data. So then you got to say, well, I selected this data. Okay, now I'm going to do a .click to trigger something on the page to react. A .click will trigger an action. Enter or type in keys, it might not trigger the action. So remember that as you're writing the code challenge. The other part here is that if you change to, let's go back to 20 results. And let's go, this time instead of we're going 100, we're going to go to 50. Watch this DOM right here. Okay, watch all these results. I'm going to hit 50. The results are there. So if your code runs too fast, you didn't get all the results. It took about 2 seconds there. Sometimes it takes 5 seconds. Sometimes it takes 1 second. It's dynamic. So how do you target that? Watch this.
Can you do that again?
Yeah.
I missed what?
So notice this number right here.
Where? The 265?
Yeah, so watch this number right here.
Oh, 1 to 100 or 265.
When I change to 50,
Uh-huh.
it took a while for it to change to 50,
Yeah.
right? Remember, our automation code is going to run as fast as it's going to be running.
Oh, I
So
thought you were saying
you-
the 265
The
change.
elements for the list that it loads, do those stay on the page?
Yes,
Oh,
the results
so
stay.
You don't want to that.
You don't want to look for it immediately after you trigger it because you're not going to get all the results. That's why I added 100 in there, because you're going to get 20 if you didn't do it right. You'll still have results, but you got 20, and you're like, that doesn't look like the whole entire
So you
page.
need like a weight.
You have to use a weight. So what do you wait on in this scenario?
For that one to whatever to change to whatever you selected.
You can wait for this number right here. That's a possibility.
What about the bottom?
Bottom of the page is another possibility. But one thing you got to remember, watch this spinner right here. It disappears. There are a lot of pages. This page doesn't have that example, but a lot of pages, when they show a spinner, they will put a whole entire gray locking div onto the page. If you put a gray locking div onto the page and you're looking for this number 20, they'll say element cannot be interacted with, so your code will break. So now you guys say, well, what do I need to watch? I'm going to watch for the invisibility of this, because the second I trigger this action, that's going to pop up. It's going to pop up just slightly faster than your automation code can execute. So you're going to watch an element, watch it for disappear. Once it disappears, you know your results are ready. So that's when you're going to grab your result.
How do you get the element for that? How do you identify that spinning pinwheel? I mean, it's only up there for a few seconds. How do you inspect for that?
Good question. So let's do this. We're going to do here. And we're going to change to 2. Yep. So notice that if you, sorry, my browser at 720p doesn't show you a whole lot. But if you watch this action in here, notice he's interacting or highlighting. Okay, and then you're going to say, oh, server-side data processing and display none. Guess what? You don't have to leave it at that. You can display block. So you're just changing their HTML now. And when you change your HTML, you can see the spinner right here.
It's always going to see if you change it in the console.
Yes.
Yeah, can we get it out of the console too? I'm sorry, what did you say, Mike?
Well, so because you have the console open, you change in the console, now it's not going to do anything.
Yeah.
You change it to the console.
Yep.
Well, in the elements, yeah.
But you can also do
That's just source.
Yeah, this is just HTML source. All you're doing is just manipulating the HTML source so you can see how to target it. Because most of the time you don't know if that is right element. If this is too quick. If this is too quick right here, and you can't grab that, because a lot of people say, well, I'm going to try to grab that. If you're lucky enough, I'm not lucky enough. So, but what you can do is watch for changes here in your console.
Cool.
And if you say, well, I think this is it, because I see a none, and I see, if I change this, oh, change it to block. Okay, I'm going to change that to, you can, with displays, you can always do none, inline, or block. You can do block, and all of a sudden you see this. So I'm going to wait for this element to disappear. So the invisibility of element, it actually looks for this display block code. This display block explicitly, and it's actually going to look for display block none. And once it finds that, then it knows that the element's invisible to the user, and that's when you know how to interact with it.
Is it also possible to do it through the console log? Like, I mean, not the elements part of the console, but the console part of the console.
Right here?
Yeah.
No.
Okay, so when you trigger that action, it isn't going to give you anything that you can extract.
Nope.
Okay. All right.
And I can clear this, and I can go to 100. There's nothing in here. It's actually harder to interact with this console right now
Okay.
than it is to manipulate your CSS.
Or just
Okay.
use the ID or whatever.
Okay. How do
You
you?
just use the ID there and say wait.
Yeah.
Wait for is not visible.
Yep. Wait for element ID. Wait for element is not visible, and that function will expect you to have a ID, a
The
web element.
function itself though is wait for visibility, right?
Wait for invisibility.
Wait for invisibility.
Yes.
They don't use just a exclamation mark.
Mm-mm.
Okay.
There's a function called, I think it's
Invisibility.
driver.wait until dot element invisible, I think. I have the code, I just don't want to show you guys the whole entire code. And here it's going to say, well, what is the element that you want me to look at? I'm going to do driver.find element by.id, and we're going to put this little dude.
ID in there.
Yep. This ID in here. Close that out. That'll be one more. That'll be your line of code. Okay, so play around with the element visible, invisible. There's a lot more other functions in there that helps you navigate through your browsers. Okay.
Hey, don't touch it. No, don't touch it.
It's going to be recorded.
Would it be acceptable
Yeah, I
to
haven't
just,
seen last
to
week's
just
recording.
give it a weight of a certain amount of seconds?
Yeah, we haven't seen last
I
week.
mean,
Yes, you can.
like that might slow things down.
You can say, do I want to wait for 5 seconds?
Yeah.
What if the results takes 30 seconds to return back because there's too many people on the site?
Yeah, that would vary a good bit.
Your code becomes very brittle.
Okay.
So you don't want to do artificial weights if you don't have to.
Okay.
If you're absolutely out of ideas, use artificial weight.
Maybe
But-
that's a way to see if the rest of the code works.
Right.
And
Read
then
it.
work on trying to do that way.
Yes.
Okay.
But you always want to make sure you are interacting with the browser and not just because you went and got a drink.
Right.
Because you want your automation to run as quickly as possible.
Yes. And it's way more fun.
Okay. So now, how do you guys write a switch statement?
Switch.
Switch.
Condition.
Switch.
Condition.
Condition. Or string.
Value or
Or
whatever.
value. Whatever that is. And then
The case.
case.
Whatever the condition you want it to equal.
Case.
1,
1.
colon,
Whoops.
and then what you want it to do,
Yep. Do something.
and then
for-
break.
And then, yes, you have to have this break. And then case 2.
Yep.
Yep.
And you have to have a default.
Do second something for me. Break. And then you're going to have to do a default. This means that if it doesn't match any of these other ones, we're just going to default.
So do the least likelies first, and then just what will be the most as your default.
Yeah.
That's how my brain thinks.
Now what if you got, let's see, whatever, break. Okay. Now what happens if you put default up here?
It'll try to match that first.
Yeah.
Whatever's, yeah.
So it's this is all it's gonna run.
Yep. You want your
But
most.
you want your least likely to be the first ones.
Yep.
or else it'll always hit the default.
Yep. So that's why this code right here will spit out 17 rear-end, 2, 29 miscellaneous. That's the default. Okay.
Oh, default is whatever doesn't match the other values.
Yep.
Yep.
Yes. Let's see. What else do I need to remember?
Switches are fun. I like switches.
So here's another one.
Hate if
This one I will give you the command for.
It's going to give us another command. And I just took pictures.
Yep. You're going to have this driver.manage.window.maximize. Yeah, I'm going to show you the importance of this.
Nice.
What's that?
I was wondering how we're going to set the maximum.
Yeah. Now let me show you what happens after you take the photo.
Okay.
Hold on, I want to take a photo.
So by default, with my Chrome, I don't know if it's a setting or what, it opens up my browser like this on this screen. At home, I have a 42-inch screen. It opens up half the page. Look at the data on this page and notice what is missing.
Search.
Well, also the data that you're trying to find, like
Yeah.
where the
It's because
dents are and stuff.
Yep, this site is responsive. So if your browser isn't wide enough, it's going to start hiding data. Guess where that data is? Now, remember, when you test with WebDriver, you are literally acting as the end user. So whatever you see on the page is what you can interact with. If it is hidden, you cannot interact with it. You cannot grab the data. So in this scenario, if you don't do a maximize your browser, your case will never ever work. The only thing that you're going to get is empty list, which is all 100 miscellaneous. Okay. Yeah.
So that's weird. I would think that the driver would, the Chrome driver that gets updated all the time, does have like a default resolution?
No, it does not.
Yeah,
Because you can actually in Chrome.
So why would the driver ever scrunch it up and hide some of the data to the responsive design?
The responsive design is impartial to what Chrome is building.
Right.
Right. So a developer can say anything that's less than 400 pixels, then I go down to or if it's 300 pixels or 200 pixels. But on this page, it's actually I think like 700 plus something.
Well, I guess what I'm asking is why would the automation script care? Why would the automation script care about the display size?
Because if
I'm writing the script on my phone or something, and it's not showing anything, I can see that being a problem.
Right, but on this page here, it's hiding the code that's written on the page.
Yeah.
Is automatically hiding your data for you.
Yeah.
So how are you going to get around that?
Well, I mean.
And most of the time, as a user, are you going to use it in a really small screen like this?
Yeah.
Scrunched up?
No.
Or are you going to be pretty much a desktop resolution?
Yeah, exactly.
Right. So to get around that, you can set your specific resolution right here. Instead of doing .maximize, you can do a set size.
Okay.
So the .maximize is just easier just to say, just maximize the whole entire thing so I can see all the data.
But you'll have to we'll have to work out the commands for Mac, because Mac doesn't have a nice little maximize.
That's right, huh?
Oh, boo.
Okay. I will find the code and send it to you.
Yay for the Windows machine.
Yes. The other thing is if you guys ever want to do mobile automation, you can tell your browser to emulate a iPhone X or Pixel or iPad, and this is how you would write your automation against mobile. So instead of using a mobile device, you can emulate a iPad. So that's why sometimes your code might not work in that scenario.
Wait a minute, how'd you do that?
So in inspect, there's a little, there it is, tab.
Yeah.
Toggle device.
No way.
Yeah.
I use that.
You just taught me
I was
something.
gonna say.
all day because I'm writing.
That's so
forms
cool.
and that stuff.
Yeah, because I have the thing that I'm going to be on. Has to run on iPad. I was going, how many test iPad, man?
Yeah. Instead of testing on real iPad, just use the emulation if it's a responsive web. And you can
identically.
not 100%. You're close to about 90%.
Then you have to do the stupid code in Mac, and it has an emulator.
So
Sorry
there's
that
like-
y'all are haters.
I'm not hating.
I'm not a hater of Mac. I just don't have one for work.
and then
Everyone on my team has a Mac but me. And my laptop only has 8 gigs of RAM in it. Oh, I already did today.
okay, here's one more thing. So remember we have to use awaits
Yeah, gotta love those.
for driver dot element, right? So let's say do array element dot get text to get the text of the element. Otherwise, if you don't do the wait, what do you get?
You get errors. Get
Yeah.
crap.
You get promise,
Promise not
pending.
pending or something.
Da-da-da. So if you do, if you do this, all of a sudden you have 100 miscellaneous items. What the crap? So remember, use your console.log, and you can do the wait array dot get text. That will print out the text. Here's a caveat. When I was debugging this, for some reason, if I stuck this value up into this condition, because it's a string, that does not work. I couldn't figure out why it wouldn't work. It would always go down to the default. So what I had to do is do var model equals, paste that there, and then do the model. That worked. So there's a couple caveats. So
Oh, you have to say more pictures.
no, I'm not going to give you the picture for this one. I want you to you guys to suffer through that one.
And then you'll just get lots of slacks from me saying, see why you should have let me take a picture?
No, I want you guys to figure this stuff out.
I figured out a lot this time. It's someone else's turn.
I gotta catch up first.
Okay. All right. I'll hold you to that.
Any
Where are you
questions?
behind in? What challenge are you on?
I just finished challenge 2 today.
What's that?
Nothing, I was talking to myself.
Okay.
I mean, this can wait till after because I might be the only one. I don't quite understand why the resolution thing is an issue because your automation script it's bypassing the display. So
It's not bypassing the display. Remember, your automation.
The display also changes, so now it's hiding the data, and you have extra buttons to click to view it. Whereas in the other format, you can just see it.
Oh, right, because what it's doing is it's calling the driver. The driver's opening up a web page and then running the test on that.
Yeah.
So if the web page that it opens is low resolution, there's your problem.
Yeah.
Gotcha.
Because remember, this is all dynamic data.
Okay, right, because it's trying to find an element that's like, okay, I get it, thank you.
Okay.
5 billion. Yeah.
The defaults are the last
Couldn't
one.
you also just sort of set the defaults on your Chrome so that it always opens it up as big as possible?
You can, but on a 42-inch screen, what if I want to run my automation while I'm doing work? If I got a whole entire suite of automation, like my automation suite, it will take me roughly about 2 hours to run on 4 machines running 5 threads each. That takes an hour and a half. Do I really want to watch? If I only have it running on my single machine, it's going to take me 6 to 8 hours. I'm going to have stuff flashing all the time. Do I really want to maximize every time a browser opens up and closes, and I'm sitting there doing work, open and closes, open and closes, open and closes?
Oh, I got you.
Yeah. So that's the reason why.
Yeah, work to get a 42-inch machine.
Okay.
So
I have a question,
Okay.
but it's not on that, so I'll wait till after class.
Okay. So if you don't have any questions, this is the material we're going to present this week, and then go ahead and do the homework. We'll have this recording available sometime.
Yeah, because we didn't get last week.